Atoms join together to form compounds that are held together by ionic bonds. Sodium chloride is such an example. It is our table salt. Sodium has an atomic number of 11 and its atomic mass is 23. Chlorine has an atomic number of 17 and an atomic mass of 35. Let's draw sodium. Sodium has 11 protons and 12 neutrons. It also has 11 electrons. So 2 electrons are placed in the first shell and the 8 electrons are in the second shell. We have 1 electron left, and that is in the outer shell or valence shell. The outer shell is not filled. So let's take a look at chlorine. Chlorine has 17 protons and 18 neutrons. It will have 17 electrons. So the first shell has 2 electrons. The second shell will have 8 electrons. 2 plus 8 is 10. So we still have 7 electrons left, and that will go on the outer shell. And this outer shell is not complete. It needs 1 more electron to complete its shell. So when sodium comes in contact with chlorine, it donates an electron to chlorine. When this happens, the sodium has its second shell filled and chlorine has its outer shell filled as well. However, since sodium has donated an electron, the charge of sodium changes. It becomes more positive because it has given up 1 negative charge. The chloride, on the other hand, has received an electron, and so it has received a negative charge, and so it has 1 extra negative charge. As a result, chlorine becomes a chloride ion, which is now negative. The opposites attract, and these 2 ions are held together by an ionic bond, and that's how we get sodium chloride. So let's look at another example of an ionic bond. This time, we'll look at potassium chloride. Potassium has an atomic number of 19 and an atomic mass of 39. Chlorine, as we know, has an atomic number of 17 and atomic mass of 35. So let's draw potassium. Potassium has 19 protons and 20 neutrons. So it should have 19 electrons to start with. So we'll put 2 on the first shell. We know that the second shell should contain 8. So that's 8 electrons. The third shell will also contain 8 electrons. So that's 2 plus 8 is 10. 10 plus 8 is 18. We still have 1 electron left. We need to create another shell, and in that shell we'll put the last electron. Remember, this shell is by no means filled. Chlorine, as we did earlier, 17 protons and 18 neutrons. The inner shell contains 2 electrons. The next shell will contain 8. So 2 plus 8 is 10. So we need 7 more electrons on the outer shell. If chlorine receives 1 more electron, then its shell will be filled. So the potassium is going to donate an electron to chlorine, as we saw earlier with the sodium. And this will allow potassium to have its third shell filled. And as a result, potassium becomes positive because it loses an electron. So we have 19 positive charges and only 18 negative charges. It's a positively charged ion. Chloride, on the other hand, has become negative because it has received an electron and received an extra negative charge. So chloride ion and potassium ion, opposites attract, and they form potassium chloride, and this is held together by an ionic bond. Let's recap what we know about ionic bonds. Ionic bonds are weak bonds. They are broken easily, even in the presence of water. We know that they are formed by donating or receiving electrons. They are formed between oppositely charged ions. The examples of compounds that are held together by ionic bonds are potassium chloride and calcium chloride. Let's have a look at the formation of a covalent bond. A covalent bond is a strong bond, and it is formed by sharing electrons between atoms. Let's take a look at hydrogen. Hydrogen has no neutrons. It has only one proton and one electron, and that electron is in the first shell. The first shell is not filled. It needs one more electron to be filled. So when two hydrogens come very close together and share their electrons, then their outer shells are filled. So hydrogen is a single covalent bond formed by sharing a single pair of electrons. And this is a strong bond. Let's take a look at another example of a covalent bond. This time we'll look at oxygen atoms. When two oxygen atoms come together, they share two pairs of electrons and form a double bond between the two oxygen atoms. Oxygen has 8 protons and 8 neutrons. So the first shell has 2 electrons. The second shell has 6 electrons. It needs 2 more electrons to complete its second shell. So when two oxygen atoms come really close together, they intersect each other, they can share 2 pairs of electrons. So let's see that. You have 2 electrons on the inner shell and the 6 electrons in the outer shell. So what happens is that the electrons can be shared between the two atoms. This way we form 2 bonds. It's a double bond between the oxygen atoms. So oxygen is written as O double bond O. Let's take a look at the covalent bond that is formed to make water. Water is H2O, so it has 2 hydrogen atoms and 1 oxygen atom. And covalent bonds are present between the hydrogens and the oxygen. So here's how it's written. The structural formula is written as OHH, and these are single bonds. So let's draw the oxygen. Oxygen, as we know, has 8 protons and 8 neutrons. It should have 8 electrons. So you will have 2 electrons on the inner shell and the remaining 6 in the outer shell. We need to fill this outer shell, and so electrons are shared with hydrogens, the 2 hydrogen atoms, in order to fill the shell. So let's draw the hydrogen. You have 1 proton in hydrogen. It comes real close to the oxygen atom and shares its electron with oxygen. So there's the electron that it shares with oxygen. The same thing happens with the other hydrogen atom as well. Your 1 proton and the electron shell, and there's the electron. Here we have a covalent bond between the hydrogen and the oxygen. However, the oxygen being much bigger than the hydrogen, it tends to pull those electrons towards itself. So the oxygen, because it pulls the electrons towards itself, it becomes a little bit negative, partially negative. The hydrogen gives up its electron a little bit towards the oxygen, and so it becomes partially positive. So that little sign that you see there is partial positive charge and partial negative charge. So that's why we say that water is a polar molecule, and because it has a positive end and a negative end, and the electrons are shared unequally. And this type of bond is called a polar covalent bond because electrons are shared unequally. Now let's compare a polar covalent bond versus a non-polar covalent bond. The difference here is how the electrons are shared. If the electrons are shared equally, then we have a non-polar covalent bond. If we have electrons shared unequally, we have a polar covalent bond. We just saw the example of water. Electrons are shared unequally in the formation of water. So oxygen is slightly negative and the hydrogens are slightly positive. So here we have a polar covalent bond because there are opposite poles that are formed in the molecule that's made as a result. Electrons are shared unequally. That's what we need to remember. Let's compare this to a non-polar covalent bond. We just saw a double bond between oxygen atoms, and here both oxygen atoms are equal in size and they share the electrons equally. In non-polar covalent bonds, there is no charge in the opposite ends of the molecule and the electrons are shared equally. It's because the electrons are shared equally that you don't have the charges in the different parts of the molecule. Since water is a polar molecule, it is a great solvent. It allows salts such as sodium chloride to dissolve. So how does that happen? Sodium and chloride break up into sodium ions and chloride ions, and water molecules surround them in an interesting way. The oxygen part of the water molecule, which is partially negative, tends to face the sodium. On the other hand, the chloride ion is surrounded by water molecules on the hydrogen side. The hydrogen atoms are partially positively charged and so they face the chloride ion. In this way, the salt dissolves in water. Let's recap what we know about covalent bonds. Covalent bonds are strong bonds. They are formed when electrons are shared. Electrons are shared equally or unequally. When they are shared equally, non-polar covalent bonds are formed. When they are shared unequally, polar covalent bonds are formed. Some examples of molecules that are held together by covalent bonds are methane, hydrogen, oxygen, and water. Let's take a look at the arrangement of water molecules and the bonds that are formed between the water molecules. What holds the water molecules together? So here we have 3 water molecules with their oxygens and their hydrogen atoms. The covalent bonds are formed within the water molecule. That's what makes the water molecule, between the oxygen and the hydrogen. And between the water molecules, hydrogen bonds are formed. It is a bond between hydrogen and oxygen. So in each case, we see that there is a bond between hydrogen and oxygen. Hydrogen bonds are weak bonds. They break when the temperature increases. So within the water molecule, we have covalent bonds, and between water molecules, we have hydrogen bonds. Let's recap what we know about hydrogen bonds. Hydrogen bonds are weak bonds. They are formed between hydrogen and some other atom. Hydrogen bonds are found between water molecules.